Hi, I am Alwyn Wilson, along with my teammate John Babu of Semester 3, Electronics and Communication Department students of Christ College of Engineering, here to give a video presentation on our course project for Logic Circuit and Design. And we have made up with a project called Robotic Arm with 4 degrees of freedom. And moving on, next I'm going to give a brief idea or an abstract about our project. We have been working on a 4-degree freedom robotic arm. It is controlled by Arduino Uno R3 microcontroller, which accepts input signals by means of a set of potentiometers. The arms is made up of 4 rotary joints and an end effector or a gripper at the end, where rotary motions is provided by a servo motor. Each link has been first designed and then fabricated using 2 mm thick acrylic sheet. The servo motors and the links are thus assembled into the final shape into the arm, and the Arduino has been programmed to provide rotation to each servo motor on rotation of the potentiometer shaft. The robotic arms are typically classified in the terms of their freedom or the number of the freedoms. Usually the number of degree of freedom represent how much the arm can move, and here we have 4 degree of freedom, which give access to the all 3-dimensional space movement of the arm. That's all. As we can see, the base part has the freedom of 180-degree motion, and above that there is another servo which provides us with the forward and the backward movement of the gripper. Just opposite to that, we have another servo which helps in the upward and the downward motion of the gripper. As we can see, the base part including the 3 servo has 180 degree of motion, and talking about the gripper, it has 90 degree of freedom for motion, which is used for pick and drop purposes.
So hi, I am John, and following up with what Alwyn has said, I'll be discussing about the materials required for the project. We've used an Arduino Uno R3 microcontroller, a few male-to-male jumper wires, a breadboard, 4 10K potentiometers, and 4 SD90 microservos. And for the basic framework of the robotic arm, we've used a laser-cut acrylic sheet. Now moving on to the working of the robotic arm, it has 4 degrees of freedom and it is controlled with an Arduino Uno R3 microcontroller as mentioned before, and the connections were made on the breadboard as shown on the circuit. On turning the knob of the potentiometer by a certain amount, the resistance between the input and the output stays the same, but the resistance between the input and the slider terminal as well as the output and the slider terminal changes. The turning of the potentiometer knob controls the degree of rotation of the microservo, and this is fed into the analog input of the microcontroller. The servos are connected to the framework of the robotic arm, with one controlling the base axis, one controlling the upward and downward motion, another for the forward and backward motion, and one for the end effector or the gripper. The Arduino has been programmed to provide rotation to each servo motor corresponding to the amount of rotation of the potentiometer shaft, which subsequently controls the 4 degrees of robotic arm framework. The robotic arm has various applications in the industry, showing its dominance in the automation processes. It is most widely used in assembly and pick-and-place applications, and it is also used for multiple industrial applications from welding, material handling, thermal spraying, and painting to drilling. So the robotic technology also provides a human-like dexterity in an environment, making our lives more easier and more productive.